Hello, our most valued student. My name is Confident and welcome to a quick revision session for Mathematics N4. So if you guys are preparing for your Math N4 exams, this is one of the revision sessions that can help you. And I'm looking at the paper that was written as I'm doing this video. Is the latest paper in August 2023. So we're going to look at question 1. But let me just check a few instructions here. My rounding off is to 3 decimal places. Okay, so that I must remember. Now let us look at question 1 of this paper. So I'm going to do question 1 and then question 2 and so on and see where it leads. So let's start with question number 1. Question 1 here, it says draw the inverse, the inverse of a graph. Draw the inverse of y is equal to that. So now you have got two options. You can actually find the inverse if you want, or you can draw this graph and then the inverse of that graph is reflected along the line y is equal to x. But I prefer the other one, whereby I find the inverse, right? The inverse of the graph. It might bring in a lot of working, but it's fine. So if you are given y is equal to 2 times 3 to the power negative x, how do you find the inverse? You interchange. Where there is y, you put x is equal to 2 times 3 to the power negative y, just like that. And then you just make y the subject. You make y the subject again. Okay, that is how you just do the inverse. Here in the first part, you interchange the variables here. Interchange the variables, meaning you interchange your x and y. Are you with me? And then from here, we're making y the subject of the formula. What do we do? First of all, there is that 2, we divide by 2, and then we're going to have x over 2 is equal to 3 to the power negative y. And then since y is a power or an exponent, we introduce logarithms. So we say log x, or ln, but let's do log. Log x over 2 is equal to negative y. We drop that. Then log 3. I hope you know it was going to pull before dropping this, before dropping it. You know what it was supposed to be? Before I drop it, it was supposed to be 3 to the power negative y. And then this one, as I'm saying, you drop it down there. Okay, that's why I'm just dropping it like that. And then what do we need? We need to make y the subject. So you divide by log 3, not only log 3, but by negative log 3, so that goes. And then that goes. So what you do on the left, let's do it also on the right. We divide by negative log 3, and then our final answer is that. But you can take this log 3, this negative will affect the top, but you can take this log 3 to become the base here. You are using the laws of logarithms. Okay, it can become the base. So what will it become? This will become log in base 3 of what? Of x over 2 is equal to y. Are you with me? So now we know our y. Therefore y is equal to log in base 3 of x over 2. This is the inverse. This is the what? The inverse function. That's why I'm saying you might not get marks on that, because they just want you to draw this graph. So what are they saying here? They're saying draw the graph of y is equal to log 3 and then x over 2. Alright, so this is the graph that we're supposed to draw. So if I can now sketch, it's a sketch, guys, it's a sketch graph. So you don't have to be very accurate. The graph of logs, you need to be knowing it. So this is our y, this is our x. You just get a few points that you want. For example, there is a point, I need the x-intercept, So the x-intercept, let me see if I can get the x-intercept where it cuts the x-axis. Y is equal to what? 0. You see that? So on the x-intercept, y is equal to 0. You can work it like that to say 0 is equal to log 3x over 2. Then 3 to the power of 0 is equal to x over 2. What is 3 to the power of 0? It's 1 is equal to x over 2. Then you multiply by 2 both sides. There it is, x is equal to what? X is equal to 2, which makes sense if you put 2 here. If you put the number 2 here, 2 over 2 is 1. Log 1 of any base is 0. So that is that part. Alright. So we know the x-intercept. If I can mark it, let's say this point here can become 2. Alright, so the graph will cut there. Now you need to just understand the logs here. Oh, let me not forget something important. The negative sign. I don't know why I left it. We said there must be that negative sign here. Remember the negative sign. So we need to understand the general graphs when it comes to log. So there is a negative here. Alright, so we are saying you can test with a calculator. Let's, for example, take a calculator. Let's say you're in the exam and you're just stuck. You can test with the calculator to say, here we are given negative log in base 3, and then you choose any number. For example, you make x negative. So you say negative, if x is negative, let's say 5 over 3. See, you get an error, which means x cannot be negative. You see, because there is no log of a negative. So x cannot be negative, which means x is only positive. So now you say 5 over 3, you get a negative answer. So when x is positive, look at the final answer. Y is what? Y is negative. That is after what? The 5 is after 2. Remember the x-intercept. Let's continue after 2, after our line 2, and then we put 400. I just choose 2 numbers. You see, if x is after 400, y is negative. Let me go before 2, because 2 is the intercept. Let me say if x is 1, for example. You see, if x is 1, I'm getting y is 1. We can have that point to say if x is 1, it's a very important one. If x is 1, we can use this point to say even here y is equal to 1. Do you see that we've got something positive before the what? Before the x-intercept. So let's try to look at other numbers, but you can see the shape. Remember, you need to know the shape of the logs. Alright. So now let's try negative log base 3 of, again, fraction. I will use any number before, which is 0.5 over 2. It was x over 2. See, I'm getting even a what? A positive number. Let's make it small even further. 0.0000, let's say 4. The more it becomes very small, you see, it gets more positive. So what you're having, you need to, as I say, the shape. Remember the shape of exponents. Exponents, they take this shape. If you are drawing an exponent, they kind of take this shape. Alright, these are exponents. But now when you're dealing with logs, as I said, you are reflecting along this line. Y is equal to x. Are you with me? So when you're reflecting along this line, you start to meet a reflection like this. You see that? So this is now log. So this is log. This is exponent. Exponential graph. So you need to be able to pick that. So if we were to draw now this graph is actually coming like this. This is the graph of log, you know. So it's going up, it's going this way. Are you with me? And then this is the graph of y is equal to negative log in base 3 of x over 2. Or you can call it the graph of the original. Remember, they say draw the inverse. So this is the graph of 2, the inverse. So you say inverse of 2. This is y is equal to 2.3 to the power negative x. This is the inverse graph. Are you with me? So as I said, you could have drawn the normal graph. Now the normal graph of this one, you could have seen it was going to be like this. Let me use, remember you are reflecting along this line, so the normal graph here of this one, I think it was somewhere down here like this, to say I think it was a graph more like this, you know, something like that. But let me not just go and confuse you, but this is the graph. Okay, let's move on. And then what do we have? It says 1.1.1. we need to write what is the domain of the inverse of this, the inverse. We are still focusing on the inverse. Now domain are the x values of this graph. So if you look at the x values of this graph, we all agree that this graph is starting from what? From x is equal to 0. Remember, let me use a different one. It's starting from x is equal to 0 here to this direction. Are you seeing that? So, but it's not going to touch. The x is equal to 0 is an asymptote, if you can say that. So simple, the domain here, 1.1.1, is x must be greater than 0. Are you getting that? That is the domain. Or some they write it like this. X is an element of 0 to infinity, because it continues to infinity, this direction. So some they write it like that. It's still gonna give you the answer. 1.1.2, what is it saying? It says here, what is the range of the inverse? Now range means the y values. Range is the y values. So you start by saying y is equal to, you can see y here, if you look at this, y is going up and y is going down. What? To infinity, you see? So this is positive infinity and this is negative infinity. So y simple is an element of what? Of real numbers. All the real numbers, you can write it like that. Y is an, or you can say y is an element of negative infinity to positive infinity. They'll still give you a mark for that. Alright, so guys, apologies for the background noise. I just wanted to bring you this video as early as possible, but I had to do it unfortunately in the midst of noise. Next one. So we are okay, we are done with this one, question 1.1. So let me erase. Let's come to 1.2. Draw the graph of x is equal to what? Minus 8 over y. You see, they're just confusing you here. They're saying draw the graph of what? Of x is equal to minus 8 over y. Doesn't matter whether it's 8 is that, but first of all, you make y the subject of the formula over 1. You multiply by y, you multiply by y. So here you have got xy is equal to negative 8. You can see this is a what? This is a hyperbola. Divide by y, divide by y. I mean that by x, because we're looking for y. So we divide both sides by x. As I say, it's a hyperbola. Then you get to a graph of y is equal to negative 8 over x. Are you with me? So you remind yourself, this is a hyperbola. So when you're sketching, of course they're saying draw the graph, but they're saying sketch. They are not sensitive to actual numbers. They want the shape. So you've got your y-axis, very important. Don't forget to label them. And the arrows are very important. Now, we have always got the x-intercept. You see, when x is 0, when x becomes 0, this graph becomes undefined. Meaning, the y-axis is the what? Not intercept, but what do you call those? Is the, I just mentioned that word. It will never touch that graph, is the asymptote. Y is equal to 0 is asymptote. And you need to know the shape of these graphs. When x is positive, let me just change there to show you. If it was a positive here, if it was positive, not negative, you need to know that this is the first quadrant and the third quadrant. So it's number 1 and number 3, which means we have got a negative 1. So we expect our graph to be in what? In the third here, in the second and fourth. You see, that's expected. You need to know why. Because of this negative here that we're given, that negative there. Are you with me? So now when you're drawing your graph, expect your graph to be in those two quadrants. All right. So now when I'm drawing, then this graph is going to be in a way here. Let me just take this off. It's going to be what? When y, you can just choose any point, but it's not necessary here. When when x is 1, y is -8. So you see, when x is 1, you can put 1 x here, and x is 1, and then you put -8, just 2 points. But as I say, it's not a must. It's not a must. And then when x is -1, here is -1. And then what is y? Y is 8. You see, you are just using those 2 points. That's why I'm saying here y is 8, but the point is somewhere there. So we are looking at a graph that goes like this. When you're drawing it, it approaches y. I need to be very smooth on my graph, like this. That was better. And like this. That was better. This is the graph, so you can put your arrows there. It goes approaching the y-axis, which is so there are two asymptotes. The y-axis is the asymptote, and the x-axis, it will never touch that line. That is the hyperbola, guys. This is basic from lower grades, but just bringing it to you again. Is graph x this asymmetrical about the x-axis? Now they are saying, picture this. When asymmetrical means the line of symmetry. If you put it like this, you can see that it's not, but the line of symmetry comes here. This is the line of symmetry, and the line of symmetry is here. Y is equal to x. So if they said asymmetrical about the line y is equal to x, it was going to be fine. Or it is also asymmetrical about the line y is equal to what? -x. Here, that is the line of symmetry. Y is equal to -x. So the answer here that they are giving here is no. Is the graph of this asymmetrical about then the answer here is no. It is asymmetrical about the line y is equal to x, or y is equal to -x. Just reminding you further if they say what is the line of symmetry of those graphs. Alright, done there. Let's go to 1.3. I'm going to erase 1.3. Draw the graph of x is equal to this. How many marks? 3 marks. So it's just drawing the graphs. This, as you can see, it looks, whenever you see such y squared and x, this is more of a circle. So let's draw it. X is equal to, you need to, after practice, you need to be able to see this very, very quick. It's negative square root of 9 minus y squared. All right. So this is the, if you can literally try to solve this, you will see that this is the equation of a circle. For example, if I multiply or divide by a -1, that cancels, right? So if I do that on both sides, what am I going to have? I'm going to have here, okay, I'm going to have, if I divide by -1 here, I'm going to have -x is equal to square root of 9 minus y squared. Then I square both sides. If you square both sides and you square both sides, so it will be x squared is equal to 9 minus y squared. Then I take y to the other side, so I've got x squared plus y squared is equal to 9, which is 3 squared. And this is the equation of a circle, which is what? X squared plus y squared is equal to r squared. But now they want you to draw not the equation of a circle. If we're drawing the equation of a circle, this is what you're going to have. You know, if we can just settle that. This is what we're going to have to say, this is my y, this is my x, right? So we're just going to have a perfect circle like this. Sorry, I'm not good in what I'm doing, but it was going to be like this. This is the graph of x squared plus y squared is equal to r squared, the equation of a circle. But now they are saying we need to restrict it. X must be negative. Look at the restrictions. X must be negative. And where is x negative? X is negative this direction. Okay, so it's negative x. All right, and then at the same time they are saying when x is negative, so you expect your graph to be like this, semicircle, so that x will never be positive. So that is the graph. But here, you know what we did. 9, you find the square root of 9, which is what? 3. Please don't forget that. So you put 3 there, you put minus 3 there. You don't need to come to this side. You don't need to do this. You just need to find yourself to say, this is your r squared. So you say r squared is equal to 9. Therefore, r is square root of 9, which is equal to 3. That's the radius. So that's why I put 3 and minus 3. So that is that, guys. That's how you draw this graph. And then they're saying 1.3.1 is the graph x is equal to this, a function or a relation. This graph is not a function, because if you want to test functionality, you test with a horizontal line, it will work. One value, actually with a vertical line test, sorry. The vertical line test will fail, because what I say, one value of x gives 2 values of y. You see, we have got here, we have got here, right? Okay, this is still fine. One value of x, no, it's actually one value of y must give 2 values of x. So if you see one value of x here giving 2 values of y, it's a relation. It's no longer a function. Actually, circles are relation graphs. They are not functions. Okay. And then let's erase there. Let's go to 1.4. Solve for the value of x if that. Okay, now we're in exponents, and then what are we given? 9 to the power of 3x minus 1 is equal to 4 to the power of 2x plus 2. Alright, so here, if I can just get more space, I'm supposed to solve for what? For x. If you're going to solve for x here, simple thing, guys, exponents. X is in the exponent and x is in the exponent. I have to introduce logs. So you just introduce logs to say log 9 to the exponent 3x minus 1 is equal to log. You can introduce ln if you want, if you're not comfortable with log. 4 to the power of 2x plus 2. You can use ln, still fine. But look, this is one thing and that is one thing. And you know the laws of exponents, you drop this and you drop it as one thing. So look how you drop it. Be careful there. 3x minus 1. Put a bracket, please. Log 9. You see? So that you avoid this situation whereby if you didn't have this bracket and this bracket, how was it going to look? It was going to look at 3x minus log 9 minus 1 log 9. Are you seeing that? So avoid that. I'm just reminding you. Is equal to, I know it's basic, but it's very important. 2x plus 2 bracket log 4. Okay. We are simplifying here. Want to find x straight away. We don't want to do a lot of things here. So open up the bracket, which is 3x log 9. I'm expanding here and here. So minus 1 log 9 is equal to, again, I'm expanding and I'm expanding, which is what? 2x log 4 plus 2 log 4. Collect like terms is the next one. Let's collect the like terms. Take x to one side and take the other rest. Since 2 is smaller, let's take it to the left. So we've got 3x log 9 and then minus 2x log 4, alright, is equal to 2 log 4 and what? Plus log 9. Guys, are you still following up? I'm not simplifying it further because I still have to work. Don't just use a calculator once. Now, when I've got here, because the 3x and the 2x, look, they're on the outside, I can factorize x here. So I'm left with 3 log 9, still allowed, minus 2 log 4. This is allowed. Are you getting it? Is equal to 2 log 4. Don't apply the laws, plus log 9. It's not necessary. Focus on x. You divide by what you don't want, which is 3 log 9. But now for the sake of your calculators, please, let's do this. For the sake of your calculators, let's take the 3 back. Take the 3 back, take the 2 back. Because your calculators will give you the wrong answer. I'll show you what I mean. So if I write it here, I'm going to then divide by log 9 cubed, I hope you see that, minus log what? 4 squared over log that 9 cubed minus log 4 squared. Now, as I say, you will see with the calculator, you need to be just sensitive. So let's find the value of x. And then let's use the calculator there. But don't forget now, it's log, to me, it's log 4 squared. You know, I'm not going to use log 2 log 4. I'll use that for the next one so that you can see the answers can change. So that you can be careful of for the next time. You see, when you punch the log, the calculator opens the bracket. You need to close it. Very important. And then log 9 cubed. Then I'll test this answer. Minus what? Minus log 4 squared. 4 squared. See that? Equal to. See, I'm getting this answer. Then I want to test it here. This is, let's not forget, 1.301. I must remember it. So for the sake of time, 1.301. So I want to test it. I'll take log 4 2 to the power 2 to the exponent 2 to the other side. It will become negative. So when I'm testing with it, this is how I test. I say log 9 to the power of, you see, 3 answer. Remember, I've got my previous answer. Remember, the calculator has got the previous answer, like that, 1.301. Let's not forget it. So I'm not, I just want to do it this fast. Log 9 to the power of 3 answer minus 1. Then you play forward, close that, and then minus, because I'm taking the other one to join 9. It's going to be negative. This one, negative log 4. I hope you see what I'm doing. To the power of 2 times answer, or 2 answer. You can put a multiplication, it's fine. Plus 2. And then you close that bracket like that. Okay, which is equal to, you see, I'm getting a 0 because x is correct. If I'm subtracting the left from the right, if I get a 0, it means the left is balancing the right hand side. Are you with me? But if I was doing it like this and say 2 log 4, you see, plus log 9, close the bracket here, over, and then I divide by, let's use the same one that we had previously. Here it was 3 log 9, remember, say 3 log 9, and then it was what, minus 2 log 4, log 4, apologies for that noise, equal to, oh okay, it gives the same answer, but I thought it was going to give something different. So I think you need to maintain this so that it doesn't give a difference, which is 1.301 here, 1.301. So that is the answer, guys, if ever you're working on this question, 1.301. Now let's move on to the next one. The last question here is 1.5, if you can erase that. Now it says expand 1 over that to 4 terms, only 4. So we have to expand, but to 4 terms using the method of binomial theorem. You see they are specific there. To expand on that, which is 1 over x minus 2 to the exponent 7, 5 marks. So let me write that. So if we are going to simplify 1 over x minus 2 to the power of 7, right? This, remember, if you take it to the top, it's simple x. You must remove that fraction, minus 2 to the power negative 7. Now, if we're going to apply the binomial expansion, let's just have a look at that. For example, I'm given x plus y to the power of n, and then I need to expand that to 4 terms, as we're saying. So the first thing that we have to do here is to take the n to the x as an exponent. Are you with me? Then we're going to take the x as an n, that's what you must write, but the y starts from 0, you multiply, and the y starts from exponent 0. Always remember that. Then that becomes our what? That becomes our first term, term number 1. Are you with me? So let me take this off for the first one. So that becomes the first one. Then when you look at the second term now, we are going to say plus, it's x, now pay attention, what you do is you go to the first term here, like you do in differentiation, you drop, you subtract 1. Are you with me? That's what happens to the x. It's more like we are performing calculus differentiation. So what you do is we continue, we say you drop the n, and then it becomes x to the power of n minus 1. Are you with me? But what happens to y? It's y to the power of 0, you add 1. So here on the other side you are subtracting like in calculus, but on the y it is increasing. That becomes our term number 2. Are you with me? Let's go to the third term. We're going to do up to 4. The same thing that we did in the second term, you grow it from there. This one you apply like we do in the calculus, you subtract 1. Are you with me? So what is it going to become? It is going to become n times, now we are dropping n minus 1, you agree with me, x to the power of minus 2. You see, remember we are separating n minus 1 as we continue there. So it will be minus 2 times y. Now look at this, y is 1 plus 1. We are adding on the y side, which is 2. Are you with me? That is our what? That is our third term. Now let's go to the fourth term. We do the same thing, but we grow it from the third term. You take that, you drop it so that it will be n minus 1, n minus 2. Then you subtract 1 there. So it will be n minus 3 as an exponent. I hope you guys are seeing. So it will be equal to, no, not equal to, but we're continuing n minus 1. Now we've dropped n minus 2, and then we've got x n minus 2 minus 1, which I'm not going to write it like that. I'll just say n minus 3 times y to the power of 2 plus 1, which, remember, y is increasing. I'm not going to write it like that. I'll just make it like this. Then these become term number 4. So when you've done this, you can now take it back to the original to say we've got x minus 2 to the power negative 7. Okay, sorry. Before that, I'm already making the error of this, and some of you have picked it up. Okay, so what is that? Let me take it back the right way. There is something very important that I'm missing out. It's the factorials. Please forgive me. On the factorials, the first one doesn't, it's 0 factorial, sorry. 0 factorial. And then the second one, it's 1 factorial. Yes, I think this works because I'm looking at the exponents. The exponent is power 2, so it must be 2 factorial. I know it's the fourth term. And then the exponent here, you see there is that 3 and that 3. So we are following that, which is the 3 factorial. I'm following that. But we start from 0 factorial. Well, 0 factorial is equal to 1. Now, if we were to expand x minus 2 to the power of negative 7. So let's come here and identify what is our what. Here, our x becomes our x, right? Remember, our y becomes our negative 2, and then our n starts from our negative 7. Just to identify that so that you can be able to follow up. So which will be equal to, let's start from 1. 1 is what? X to the power of 7, which is our x to the power of negative 7. That's our n. Times, that starting point. Y is what? Negative 2 to the power of 0. Okay. Plus, we continue, we drop. Remember now, that's why we started dropping. We drop the negative 7, and then you say x to the power of what? Negative 7, negative 1. Times y, which is negative 2, times 0 plus 1, which is 1, divided by 1 factorial. Let's not forget. 0 factorial. Plus, let's go to the third term. We are dropping negative 7. That is down. And then we have got negative 7, negative 1. What is this? This is negative 8. You see? So I'm going to drop here negative 8. And then I've got x to the power of n, which is what? Negative 7, negative 2 now. Times y, which is negative 2 squared. See that? All over 2 factorial. I think that. Then we go to the last one. Then the last one will become what? It will become negative 7, and then we've got negative 7 n minus 1, negative 7, negative 1, you know it was negative 8, and n minus 2 is negative 9 there, and then x to the power of negative 7, negative 3 is negative 10 now. See, because that is negative 9 there. You just move with it. Negative 9 is there. So we continue, and then here you have minus 2 to the power of 3. Then you have 3 factorial. Are you with me? Apologies for the hissing sound. It's my backup battery because I just had load shedding, so it's coming back. So apologies for that. Which is equal to, we simplify. So guys, any number to the power of 0 is a 1. So here we have got just simple x to the power of what? Of negative 7. Are you with me? And then, is it a minus or a plus? Negative 7 will multiply with negative 2 to give us a what? If you multiply them, a positive 14 here. So it's plus 14 x to the power of what? Negative 8. Now, what is 1 factorial? Now, let me take the calculator. Let's come back to the factorials. The factorials are also not something that must make you stress, It's just something that you can use your calculator to calculate with. But if we say 1 factorial, it's just 0 factorial is 1. 1 factorial, it's 1. 2 factorial is 1 times 2. Right? 3 factorial is 3 times 2 times 1. Are you with me? So that is what factorials actually are on. But let's use a calculator already directly. If we use here, there is the factorial, shift factorial. You see that? So if I say 1, let's start with 0. 0 shift factorial is equal to 1. And then 1 shift factorial is equal to 1, you see? And then if you say 2 shift factorial is equal to what? 2. Because it's 2 times 1. If you say 3 shift factorial, what are you going to get? You get 6. So we can move ahead and know that this was 6. But let's continue. So you will have that, we said number 2 was 14 to the power of that, divided by 1 factorial, it changes nothing, plus, then we need a calculator for the second one. We need a calculator because we are multiplying quite a number of negative 7, negative 8 times negative 2 squared. See this one? Let me put a bracket. It's negative 7 times negative 8 times bracket negative 2 squared, right, over 2 factorial, shift factorial, which we know is 2. So you've got 112. So you've got 112 x to the power of what? Negative 9. Don't forget that. And then lastly, plus, you use again the calculator to find the final one where you are dividing by the 3 factorial. That's the 4th term, which they said we must be working on. So let me just bring my calculator here. It will become here negative 7 times negative 8 times negative 9 times negative 2 cubed, all right, over 3 factorial. It gives us what? Equal to 672, which is 672 x to the power of what? Negative 10. So this is the final answer. You can leave it like that. But you can move on to give the positive exponents if you want, so that it becomes 1 over x to the power of 7. Okay, let me give it a bit of space. So you will have in here, let's drag it down so that I've got enough space. So it's 1 over x to the power of 7 here, all right, plus 14 over x to the power of 8 plus 112 over x to the power of 9 plus what? 672 over x to the power of 10. So that is the expansion, binomial expansion of this term. So I hope it does make sense. And yeah, this was the question 1.5, 4 marks. So we've come to the end of question 1.5. That's the 20 marks. And then with time allowing, I'll do question number 2 for 20 marks. Let's move on. I will also do question number 3. I will encourage you guys to subscribe so that you catch this. Question number 3 for 20 marks. Then question number 4 again for 20 marks. And then it ends with question number 5. Okay, which is also 20 marks, mainly integration and application there. So we've come to the end of our lesson. I hope you guys benefited from this one. Thank you.